take a look at all of the concepts that will be present. Hopefully you did a lot of homework in preparation. We are covering chapter 11. So all of the vectors and 2D, 3D, we have the dot product for any dimension, we have the cross product. Technically the list of title, like the title is the list of concepts, but we are going to take a look into details. Make sure that you know the formulas that are necessary for the Calculus 3. The formulas, calculus formulas, math formulas will not be provided on the test because if you have the formulas, then technically it's Calc 1, right? So that is something that you need to learn. You must learn the formulas. Okay, let's take a look. So exam will cover chapter 11. So we have 9 sections. So chapter 11, sections 11.1 through 11.9. The concepts are vectors, 2D and 3D, along with their properties and computations, calculations. So to add, subtract vectors, multiply by a scalar, find the direction, find the magnitude. So all of the important things. We also have the dot product, the cross product. Both of these have their applications. Lines and curves in space. So I'm just going to say straight line. You better know the formula, the parametrization x equal x0 plus a t, and then y equal y0 plus bt, very good. And then z equals z0 plus ct, yes, very good. Parametrization for that, and then we have parametrization for all the other lines, which is that parameter r. So curves in space are parametricized, and that's going to be our r of t, f of t, g of t, h of t. So I hope you know that by now. You know how to parametrize. The equation of the helix would be the circle for the first two. So r cosine t, comma r sine t, comma, and then whatever term there for helix, depending on how fast you want the helix to rise. So curves in space. Then we have calculus. So calc with K's, please don't misspell that. So calculus of vector valued functions. So calculus of vector valued functions. And that has the derivative for r, so you will get the r prime and then the r double prime to get the acceleration. also integration going backwards, and pay attention to getting the tangent line. Oh, nah, let's go this way. So we have r prime of t, we have r double prime of t, those are velocity and acceleration, and then we have the integrals. Make sure, in parentheses, make sure you can find vector c if the point is given. We did the example of that in class. Also for this is the tangent line. So make sure you can find the tangent line as well. 11.7 is motion in space. So that's the parabolic motion. And it's physics. So if anything shows up there, I will give you that formula. And we have lengths of curves. So we have 3 different types of lengths of curves. We have the rectangular, polar, and parametric. So 3 different formulas to find the length of curve. And then the last concept is curvature and the normal vector. It was principal unit normal vector, the full title. That was last night. It's covered last night. So that's what we have for these in concepts. Okay, so now to dig deeper into these concepts, we're talking about vectors in 2 and 3D, which means add them, subtract them, multiply by a scalar. The negative of the vector, which changes the component, the sign on each of the components, IJK notation, and also the vector notation with the spiky brackets. What else is there? We have dot product. Dot product is used for what? Angle between 2 vectors. Dot product can be computed in any dimension. And the most useful application is to find the angle, but we can find the projection in there. So there is the projection as well, projection of u onto v. There is that formula with the dot product. What else is there? So dot product, that's it. Now we use the work as the example for the dot product, so that's one of the applications.
Is unit tangent vector going to be its own separate problem, or is it going to be within the normal?
The unit tangent, oh, I didn't write, yeah, I missed to write the unit tangent vector. Wow.
Sorry, guys. My bad.
It's not your bad. By the grace of David, you...
Thanks, Dave.
which is equal to r prime divided by the r prime magnitude. Yeah, that's going to be there. That's definitely going to be there. So what do we have? What else do we have? Let's see. Cross product. So cross product. Know how to compute the cross product using the...
You can complain about this.
What?
You can complain for the voice.
Yes, when I walk away from the tablet, yeah, exactly, it doesn't pick up voice, so now I have to carry it like this. Cross product. know how to compute cross product using ijk, right? Negative j, remember that one? What was the cross product used for? To find the orthogonal. To find the orthogonal vector to any two given vectors. Orthogonal means 90 degrees to the plane. And we are going to use that as a vector that will describe the plane later on. So a very important concept. Cross product produces another vector. A straight line, we already reviewed the equation for the straight line. We need to know how to get the straight lines. The vector ABC is that, quote unquote, three-dimensional slope, which is actually the vector that gives us the direction. And then we have the point that we go through. Yes, Mary?
I thought you said the dot product was orthogonals.
The dot product, if you do dot product between two vectors, that means that the two vectors are perpendicular or orthogonal to itself. But the cross product produces new vector which is orthogonal to the plane that the other two vectors create.
So if you said find the perpendicular.
If I say find the vector and you have 3 points, then you can create two vectors from the 3 points.
Using cross product.
Yeah, you first find the two vectors and then you cross product them and you get the perpendicular vector.
So, everything was doing this line. You give us two vectors and you say...
find the perpendicular, yes.
And that's just cross product.
Cross product. Very good. If I ask you if the two vectors are perpendicular, you run a dot product. If you get the 0, they're perpendicular. If you don't get the 0, they're not.
If the dot product is 0...
If the dot product is 0, two vectors are perpendicular. Right, Rutgers? I'm a terrible person. Eventually. Curves in space. So for curves in space, we said that's the vector r. It's the vector r. So we will have, for 3 dimensions, we'll have 3 components. And each one of those is its own function. We can differentiate, it's called the vector valued function. We can differentiate, we can integrate, we can take the limits component-wise, so each one of those independently. And the original curve R is a parametrization of the path on which the particle will be moving, let's say. And if you find the first derivative, you get the velocity. You find the second derivative, you get the acceleration. If you're integrating and you have an initial point, you can compute the value of c. We did the example already. So just go back to the section, look at the example. Once you integrate, you put the vector plus c, and that vector plus c will have c1, c2, c3, and you just compute from there. Tangent line. When you find the derivative that gives you the three-dimensional slope, that ABC vector, and then you have the point in which you are looking for the line, so you can use those pieces of information to come up with the parametrization of the straight line, in which case it will be the tangent line. All of these derivatives and integrals and everything can be computed at the point at the end. So if you are getting a function at the end, which is going to be 3 functions, right? The vector valued function in terms of t, given t equals, let's say, I don't know, 5, you can compute the value and compute the position or the velocity or the speed, right? Which is what speed? Magnitude of velocity. Very good. So speed is magnitude of velocity. So simply just find the length of the vector and you're done. Lengths of curves, you need to know all 3 formulas. Rectangular formula, which was square root of 1 plus f of x prime squared dx, was taught in Calculus 2 class. We only expanded on parametrization equation and polar equation, so those 2 in addition. Whatever problem requires, just use the appropriate formula. You don't really want to, use the sledgehammer on a simple problem, but if you run into something that you cannot integrate, you might want to consider changing it into polar coordinates or changing or making a parametrization for it and then using the parametric one so you are able to do the problem. So you'll have to be witty in terms of which one out of 3 formulas to use. And the rule of thumb is if you can integrate the problem, most likely you need to transform the problem, because in that case the problem will be possible to compute. Curvature, we have that one formula with the tangent vector, right? So that's the unit tangent vector, so we use the curvature that way. And we have the normal vector, which is the derivative of the tangent vector divided by the magnitude of the derivative of the tangent vector. And then don't forget to learn, if you don't know, you should know by now. What's the formula for unit tangent vector? Yeah, it's all live. It's awesome. There we go. You all know it. So yeah, it is very good. It's r prime divided by magnitude of r prime. Very good. Very good. See, I have no fears, which means we're done with the review. We go home, right? Oh, some problems. Okay, let's do some problems then. Yeah. So hold on. One question at a time. Yeah. Given set of points, find the perpendicular vector. Okay. The first question that we are going to talk about is going to be given 3 points, find the perpendicular or orthogonal vector to the plane that those 3 points describe. First of all, guys, you need only 2 points to describe a line, because the line needs to be clamped at 2 spots, and that requires a line. You can't do that for the plane, because if you only have 2 points and you put the plane, you see it wobbles, right? The minimum requirement is to have 3 points to describe the plane. But the thing about having the 3 points is, as you can see, if you recycle 1 point, you can create 2 vectors. So anytime you have 3 points, you can create 2 vectors, and when you cross those 2 vectors, you will get the third vector, which is orthogonal to the plane. And that's called the normal vector. So let's do it. I think your ban expired for giving the problem. Let's see. What are the numbers for 3 points? Point A.
576.
576. Okay. B. So, well, it has to be 666 points every time. And then what else?
3, 2, 1.
None of the points are negative, which is very interesting. Let's pick one of these numbers to be negative somewhere.
6.
All right, good. Let's go. So first I'm going to create vector AB. Since B is the terminal point, we are going to create a vector as B minus A. So 6 minus 5 is 1, 6 minus 7 is negative 1, and 6 minus 6 is 12. Perfect. Now we're going to create one more vector. You can pick any, doesn't matter. You can go AC, or you can go BC, or you can go CB. BC. Yes?
So what was the question exactly
Find the normal, find the orthogonal vector to the plane containing these 3 points. Plane contains these 3 points. Yes, Chewy? So BC, 3 minus 6 is negative 3, 2 minus is negative 4, and then 1 minus is negative 5. Awesome. It doesn't matter. Doesn't matter which order, doesn't matter which pair. You just don't want a vector A, B, and B, A. But any other combination will work. There's 6 combinations.
Question.
Yes.
So we are now going to find out the plane by doing this.
We are going to find, well, we have 2 vectors, and these 2 vectors are defining the plane. We are going to find now the perpendicular vector by doing the cross product between these 2, and that vector is going to define a plane eventually. Next chapter. So AB cross BC is going to be IJK, and then we have 1, -1, 12, -3, -4, -5. I, we have 5 plus 48, that's about 53. It's good enough, I think. And then -J, we have -5 plus 36, so 31. And plus K, which is -4 minus 3, -7. So I think the vector is 53, -31, -7. Is anyone going to confirm that? Whatever? It's in a ballpark, right? It's in a ballpark of the partial credit. It's the best we can do for today. Kyle, happy?
Yeah.
Good, you're welcome.
But that's the normal.
That's the normal vector. Later, we're going to use this normal vector to write the equation of the plane. It's going to be an extra step, and then eventually we're going to have the tangent planes, and it's going to be awesome. But right now, we're just doing the cross product. We need to know how to compute that. Anything else?
Application of dot product.
Work, force times distance. There you go.
With an angle.
You pepper in the angle. That's good. Yeah. Yeah, you just do the cosine of it. If it's on the angle, if you're applying the force of the angle, you just use the trig to trim the function, to trim the force. That's all it is. No, I hope you're not disappointed. Unless you want a special exam. Well, it's okay. It expands your horizons. Yes. Line problem. What do you mean a line problem? Find the line what?
Equation of line? The x plus 8.
Find the line what?
Of the equation.
Maybe, I don't know, but I'll give you the formula if I do.
Can you do normal vector application?
What happened?
Normal vector, please.
Yes. It's like the most dreaded question ever. Did you find a problem? If it's already done in the notes, why are we? You just flipped. Why we're doing it again?
It doesn't hurt.
What do you mean doesn't hurt? You know all the letters and all the numbers, and you just read it and understand it. If you have a different problem from the book regarding the line, you can do it. Redoing the same problem was already done.
Different numbers.
Same thing, different numbers. All right. Anyone else?
This is the one that I got it, but now maybe this is a good question.
Wow.
Yeah, so we have to find this point of 0, 0, 0, and then we do the vector.
Then you got it.
Yeah. Maybe it's a good review. Or you're not gonna put this hard question in the
If it's hard, it's just
annoying.
you're annoying. Yeah, it's too long. It's too long for the test.
Too long?
Yeah.
Yeah.
It's too long for the test. And this is your T?
No, Tor.
Oh, the Tor.
I don't know why they put Tor.
Yeah, doesn't matter.
Is there going to be a polar coordinate conversion length problem?
Why not?
Can we do an example then?
Do an example. Not each one.
It's like a chocolate and vanilla and then strawberry.
just, like,
And then
go home. Polar coordinate.
Let's just do one with a polar one.
Mary's like, yes, please. So now I have.
She gets a second on that.
So how many problems have we now so far?
We do curvature.
Wait, can you just write out how many problems you think you'll be putting on the test? It really helps. Please.
I don't know.
Please.
Because I'm going to change my mind. And then it's going to be bad for you.
Just don't change your mind then.
But I like that. Okay, the only way to be always right is to frequently change your opinions and mine. All right? So, you have to learn that skill. Guys, we have a question on the table, so we have to go and do that question.
We make it a two-part question to find the curvature of the two.
We'll do the curvature next. Unless you have to be somewhere, and I'm gonna do your problem first, and then.
I don't have anyone.
Then enjoy this problem first, and then you'll do the rest. All right, guys. So here's the question. So find the line. No, find the length of the curve, and the curve is given as give me a number 34 through 40. 36. R equal. Wait, we did 36. Art.
37.
Yeah.
How would I know that?
You're a witch. 32?
Yeah, I actually have to
No.
that.
Yeah, I did it in your. That's why I know. I did it twice. Once over here and once in your notebook.
38.
38. Okay, Mary said 38. R equals sine squared theta over 2
Wait, no, 37.
from 0 to pi. You can't take it back. Find the length of the curve. Now this is given in polar coordinates, which means we are going to use the polar equation. Does anyone remember polar equation? L equals the integral first, I hope. It's going to be 0 to pi. It's going to be square root of? Yes. Well, first is the square, the vanilla one, and then the derivative one. It doesn't matter which one because it's plus. So it doesn't matter which one is first. All right, so guys, R is your f of theta. So f prime of theta is going to be the derivative, which is 2 sine theta over 2 times the integral of the inside is a cosine theta over, oh my, beautiful, times 1/2. Look at that. Amazing. So this is equal to, the derivative is 1/2 sine theta. Wow. Wow.
I thought it's the sine over half sine pi over 2.
What happened?
Half sine pi over 2.
The formula.
Sine theta is 2 sine theta cosine theta.
2 sine cosine is the sine of double angle, but it was theta over 2. When you make it double, it's just a theta. Okay. I'm sorry? It's a polar equation. Right?
Does that both say F prime in the right side? Where you're writing?
This is the vanilla one, and this is the derivative one.
Not next to it. What you did on the side, on the right side of the paper.
Yeah, this is the derivative over here, and this is simplified derivative.
Okay.
So let's see what we get. Integral 0 to pi square root of regular function squared is going to be sine to the fourth theta over 2, and then plus 1/4 sine squared theta, everything d theta. And now we're going to call upon calculus 2 to solve this integral. All right, so I heard something sacrilegious. Tricks up on this now. That no. Do not get to cancel the square root with squares over here. There's a plus there. No, to the fourth, because it was the sine squared is in a problem and you square it in the formula. Yes? Let's use the, well guys, now we have to figure out how to solve this, how to integrate.
Let's break up some of the fourth to sine squared times sine squared, and then do the 1 minus the cosine squared theta. Get a new sub.
But you still have plus 1/4 sine, which you can't break off in any way. So what I would like to do is I would like to do power reducing formula, just to test the waters. And if that helps, blessings, if that helps, we're good. It's math, it's very funny. Power reducing formula, 0 to pi so sine to the fourth theta over 2 can be written as sine squared theta over 2, everything squared. And then we are using the power reducing formula, which means that we are going to have the sine squared written as 1 minus cosine of double angle, which is just 2, and then the whole thing is going to be squared. It is 2 theta, but you had the theta over 2 as the input. When you double it, it becomes theta only. It is doubling the input angle. Input angle was theta over 2. So, and now we can FOIL this. We get 1/4 minus cosine theta plus cosine squared theta over 4. So I have 1/4 minus cosine theta plus 1/4 cosine squared theta plus 1/4 sine squared theta. Looking good over here. D theta. So these two terms what happened? Yeah, the first one is 1/2. You square it, you get 1/4. Then you go first times the second. First times the second is 1 times cosine, and it's doubled, which cancels the 2 on the bottom. Oh yeah, the bottom is the 4, so this is 2 over here. Very good catch. There we go. That's good now. No, it's over 2. Like this. 1/2, right? All right. So now this over here is going to give me a quarter. When I factor out the quarter, I factor out a quarter, and then sine squared plus cos squared gives me 1. And a quarter in front is give me a 1/2. So what I'm integrating is a 1/2 minus a 1/2 cosine theta, d theta. And that's the formula. That's the backwards, right? So when you put these two fractions together, you get 1 minus cosine theta over 2 d theta, which is 0 to pi square root of, this is sine squared theta over 2 d theta. Then these guys cancel, and all you need to do is 0 to pi sine theta over 2 d theta, which is derivative of sine is negative cosine of theta over 2, and then 2 in front, from 0 to pi. So negative 2 cosine of pi over 2 minus cosine of 0. Cosine of pi over 2 is 0 minus 1 is 2. Length is 2 units. How's your integration? Oh, here's how you trig functions. How you trig identities.
That won't be
Now, this particular problem can, because as you can see, it's done over here. So everyone goes home and memorizes this example verbatim. Yes, ma'am. Show me something real quick. Okay.
Could you do a problem involving something like that? That's what we would probably like a line.
Yeah, I know. Do you have it? Can you find it? This is a textbook over here? Yeah.
Section.
Yeah, I mean, I only want all of
A line through the points, the direction of the vector. That would be good,
Yeah.
It says what? Find the equation of a line that
right?
goes
It
through
says
the point.
a line. Equations are not going to see it. The line through -3 to -1 in the direction of the
We found one.
Not a dog pound?
Thank you.
Good.
So, find
Page.
the equation of a line.
806? All right. And you will tell me the problem. I need to get there. All right, guys, we have another problem. This one is going to be the equation of the line. Page 806. Problem number 10. It says, find the equation line through the point -3 to -1. Very creative. In a direction of the vector. 1, negative 2, 0. All right, so we know the formula for the line. X equals x0 plus at, y equal y0 plus bt, z equals z0 plus ct. Well, x0, y0, z0 is given to us as negative 3, 2, negative 1. And the vector v is given, which is 1, negative 2, 0. So we just plug everything in. X equals negative 3 plus t. Y equals 2 minus 2t. And z equals negative 1. Good. Done. What happened? Yeah, that's fine. This is the parametric form. If you really want to put, you can put the vector valued function like this. If that's something that's going to make you happy, please, by all means, because math is supposed to make you happy at all times.
On the previous problem, can you just go over the sign?
I will. You found the curvature problem? Hold that thought. I have to answer the question. Just don't lose the curvature problem, okay?
Okay, wait. Because I had to think about it too. And then two pencil up when that cancels out. Power, ability, thing.
All right. It's time for curvature.
It's on your phone. It's on the side. Never play with him. You would die. Literally would die. I could have. I saw one back. Have you ever watched
What do you mean Apple? I would never throw the Apple phone because I would never touch that. right. Um, you're concerned, Mary. We are supposed to find the unit tangent vector and the curvature on this problem. If anyone is paying attention still, if we are done with the review, just let me know. Not done? All right. R prime. R prime, yes. We're dreading it already. So it's 3 cosine squared t times the derivative negative sine t. And 3 sine squared t times cosine t. Well, chain rule. We're looking for the tangent unit vector and the curvature. I thought the question came from you guys. There we go. This was a question on a quiz 3. So I don't know if anyone did quiz 3 other than the people that are asking. So R prime of t is negative 3 sine t cosine squared t and 3 sine squared t cosine t are the components. I'm waiting. Understood. The next piece is to find the unit tangent vector by dividing the r prime with the magnitude of r prime, which means I have the magnitude of r prime. Square the first one, it's 9 sine squared cosine to the 4th t plus 9 sine to the 4th t cosine squared t. We can factor out 9 sine squared t cosine squared t, and what's left is cosine squared t plus sine squared t, which is 1. So 3 sine t cosine t is our the magnitude. So what's the unit tangent vector? It is r prime over its magnitude, negative 3 sine t cosine squared t, comma, 3 sine squared t cosine t, divided by the magnitude 3 sine t cosine t, t hat is equal to, the 3's are going to drop, and then from the first one sine and 1 cosine drops, so it's negative cosine t, and the second one is sine t. Hey, nice. What is the formula for curvature?
Prime over oh no, it's the whole thing. I forgot.
It's supposed to be a cheat sheet somewhere around.
Magnitude
T prime
Over magnitude
of r prime. Very good. So magnitude of the t prime divided by the magnitude of the r prime. So this is t prime. The derivative of cosine is negative sine, and then negative and negative cancel. So I have the magnitude of sine t comma cosine t divided by the magnitude of r prime. We already have that. That's 3 sine t cosine t. So now k of t is, the magnitude here is just 1. Very good. Divided by 3 sine t cosine t. And that's the answer. That's the curvature. Now if you provide a value for t, you will be looking at the exact location. So if the curve looks like this, whatever, this is over here, t equals to 0, t equals to 1, t equals to 2, t equals to 3, right? And then anything in between. So you can see that the curvature is different at each one of these points. So over here there is less curvature in this location than in that location. So the curvature can be given as a function, and if the curvature is given as a function, that it has to depend obviously on the location at which you are looking. It's like the tangent line, right? You're looking for the tangent line at the point. And at every point during the function, the tangent line will change because math. So this question was on your quiz, quiz 3, I believe. Now, as I said, not all of you get the same quizzes, right? You get modified in terms of functions and numbers. If I do, you'll have 1 second. So technically, those are considered skips. We have about 7 minutes left in class, and then another hour and 15 after that. Yeah. So if there is a physics application problem, the formula will be given, even though I said that you should know that work is force times distance. So technically, since the formula is given, it's just plug and chug. Those questions should be gifts, technically. What? On paper, like this. And there's going to be a problem, and you click a page.
Multiple part questions?
No.
No? Is it going to be like very difficulty, or does it
Very difficult, like yeah.
does it test your like knowledge on like simple like knowing what you know like dot product or cross product?
Factoring and nuclear physics and stuff, sure. I heard that my exams are rated, I don't know why, scale of 1 to 10.
If you're a one.
8. No, 8.
Oh, hardness? I mean one harder.
What you were gonna rate at 0?
No, I mean like the scale of what?
Yeah.
1 to 1 to 10.
It should be called quizzes.
1 to 5, they are rated at 8, yes. Extra spicy.
Are there going to be?
Yeah, it never happened.
Never happened.
Probably the only
No, my Dell.
what?
My Dell.
Yeah, but it's not a Dell laptop.
He said the only
It's made from the source.
Yeah. So
It's
make
the
it.
source,
The
yeah.
Mac never does this.
I don't know.
know the people that special yellow exam. You want a special exam. You want a special exam. They want a special exam. Oh yes, you want a special yellow exam. Those are harder tests that have all the.
I was just getting special yellow exam because I like yellow.
Yeah, but there are some extra spicy questions.
Like Sudoku.
I actually have never done that.
But then I would love that as a question. Add at least like an extra 15 minutes on the test. Or that could be our substitute problem or whatever.
You have no idea what kind of idea you gave me with Sudoku, and then there is the cross product, and then there is stuff, and then there is.
You want to do a cross substitute. If you only had the test that, I would totally promise that. Then you substitute the puzzle and then do the cross product.
Hold on, I'm thinking tensor calculus here. We're looking into wow. I celebrated when it got into place. I want to do a little dance. Okay, let me see if I have an answer. Like plus two. You know. Oh, you forgot. That's even worse. Yeah, 5 problems need to be done in mathematics. You do them on paper, including Wolfram. And then 5. I'm sorry. Bare minimum. That's what the average people would do. 5. And then if you want to distinguish yourself, more.
I did it.
I have a variety of Sudokus at home.
None of them, I can tell you right now that none of them actually have the cross product. But I just have them most awesome stuff.
You guys can do like parentheses and all this stuff.
I gotta work it out tonight.
It's not mine.
Oh my god. Takes a lot longer. Yeah, I used to kind of used to have this. And then I myself have I'm waiting your reaction so I can tell you.
Showing up.
Oh, okay. Oh, okay.
Who tested you? Oh my gosh! Oh my god!
Yeah. Apparently there is an issue with helix. I know. The only helix we did in class is the one that wraps around the z-axis. Hence the sine and cosine terms were on x and y, right?
Yeah.
But the helix can wrap around x-axis. Or z-axis, which is what we did in class. Or y-axis. Fun, right? So be mindful of that, right? That's another good idea that I didn't have until now. Yours.
I'm not good at explaining I forgot. Ow!
Yeah, just pointed out that there will be really cool curveball if I give you the helix that's not around z-axis, but around x or y. Yeah, which I never went over in class, which tests your knowledge of the function.
Test their knowledge of the things you didn't know.
You know what the helix is? Now you're the
The artsy.
She's got it. All right. I guess that's it for the review. Stop the stream.